All right, lesson 10.5 is about the midpoint and distance formulas. Now these are both going to use points that we have from a coordinate grid. So if we have coordinate grid right here with our x line going this way, y line going vertically, let's say we had 2 points, one here and one over here. Now the midpoint of these 2 points is just the middle spot. The distance is just the length from here all the way to here. So that's what we're trying to find. We're going to take these 2 points, use the numbers of them, our x and y values, to find the midpoint and the distance formula. So key terms, the midpoint is just the point that is equidistant from both of the endpoints. It's the same length from either of them. So if this was, let's say, the midpoint, it's the same length from here to here as it is from here to here, meaning it's right in the middle. So one of our key concepts is the midpoint formula. The midpoint M of a line segment with endpoints at x1, y1, and x2, y2 is given by this formula here. What that means is if we were to draw a line going from green point to green point, and this blue one was our midpoint, we would find it by using the x values and y values of this dot and this dot, and you plug them into this formula. What this is saying is basically it's the average of the x values, take x1 plus x2 and divide it by 2, and the average of the y values, y1 plus y2, and then divide it by 2. You're basically just finding the average x length and the average y value, and that would be how you find your midpoint. So let's see how this works in a couple of examples. We want to find the coordinates of the midpoint of the segment that has endpoints at -1, -2, and 3, -4. Now for this example, I won't do it for everyone, but I'm going to actually plot this out and we can see what that looks like. So -1, -2 is right here, 3, -4 is right here, so our line would look something like this. So this is the segment we're looking at. We want to find the midpoint of it. So to do that, we just plug it all into our formula. We're basically finding the average of our x values right here, the average of our y values right here. Now we have x1, y1, this is our first point. We have x2, y2 right here. So x1, which was -1, is right here. x2, which was 3, is right here. Same thing. y1, that -2, goes right here. y2, the second y value, goes right here. Our 2 x's added up, our 2 y's added up, and then divided by 2. So simplifying that down, we get -1 plus 3 is 2, -2 plus -4 is -6, 2 over 2 is 1, and -6 over 2 is -3. That missed a negative. I want to put that in there. -3. So we would say this is the coordinates of our endpoint. Now to double check that, I'm going to actually plot that on our graph here. So at 1, -1, 2, 3, here is our midpoint, and that makes sense. That is the spot that is exactly halfway between the two of them. So this is how we'd find it algebraically. We just plug in our numbers, finding the average x values, average y values. This is how it would look then. And this is what it looks like if you do it on a graph. Now we won't be able to graph each and every one of these, but this is how you would this is how it would look. So we're more interested in the algebraic process, just using the numbers to find that midpoint. So for this example, we want to find the coordinates of the midpoint of the segment that has endpoints at 3, -17, and 2, -8. These are our 2 points. So again, we're just finding the average x values, average y values. 3 and 2 get added up and then divided by 2. -17 and -8 get added up and then divided by 2. Simplifying that down a little bit, we get 5 over 2 and -25 over 2. Now you can leave it as a fraction in this case, or if you want, you can simplify it down and call it 2.5 and -12.5. This one would be much harder to graph because this would be really low, this -12.5, plus it wouldn't actually be on any lines. seeing 2.5 and negative 12.5, this would actually be in the middle of a box somewhere. So it wouldn't necessarily be super easy to graph it exactly. But in the end, this would be our midpoint. Now for this one, we're going to think of our concept like this. If we go from this dot to this dot, okay, this is our segment. We have our 2 points, and our midpoint is right in between them. Remember, it's going to be equidistant from the two of them. So it says, find the coordinates of the other endpoint, given that one endpoint is at 4, negative 8, and the midpoint is at 10, negative 6. Well, remember, going from here to here needs to be the same as going here to here. And what's changing is both your x and your y values. So going from this endpoint to this midpoint, and then from this midpoint onto our next endpoint, the x values should change the same amount. Here to here, x should change the same as going here to here, and the y value should change the same amount, going here to here as here to here. So when we think of that, we want to look at it as how much are we changing going from this 4 right here to this 10. Going from 4 to 10, we are adding 6, which means we need to add 6 on this side as well to get to our next point, because then 10 would be the average of these two numbers. So 10 plus 6 would be what? Our x value should be 16. So same thing for our y values, going from this negative 8 to this negative 6, right here and here. What are we doing? We're adding 2. From negative 8 to negative 6, you added 2. So to go to the next spot, we have to add 2 as well, meaning our y value should be negative 4. Now if you think about it, again, 4 and 16 would add up to 20, divided by 2 gives us 10. So this would be the average x value. That's why it's the midpoint. Same thing, negative 8 and negative 4 add up to negative 12 divided by 2 makes negative 6. So this would be our average y value. That's why it's part of the midpoint. That means that these two, the negative 4 and the negative 16, are the original endpoint, or the one that we were missing. So we would say if this was an endpoint and this was a midpoint, this has to be our other endpoint, 16, negative 4. We got 16 from here, negative 4 from here. Okay, now we're going to go on to the distance formula. Now the distance between any 2 points on our coordinate plane, again, we're going to use the same kind of points, the x1, y1, and the x2, y2. It's given by this formula. The distance, d, equals the square root of, now everything is underneath the square root. You take your x2 minus x1, whatever value you get, you square it, plus your y2 minus your y1, whatever you get there, you square it. And then everything is underneath the square root. Now, why does this work? Well, let's think about it. As we go from, I'm going to say from one point here to one point here, we're changing so much in our x value, and we're changing so much in our y value, which makes the distance right here. Now what we drew here is technically a right triangle, which means we can use the Pythagorean theorem. If this is A, this one is B, then this one is C, then A squared plus B squared equals C squared. What is this length of A squared? Well, it's x2 minus x1. So that squared, because we have to do A squared. Same thing from here to here. The change of our y values is B, so it's right here. Change of our y values, then squared. So this squared plus this squared should equal d, the distance, squared. Well, we don't want the distance squared, we want just the distance, which is why we have to do the square root on this side. So that's how the distance formula works, or why it works. When we plug everything in and take the square root, you will get your correct distance. So for our examples, we're going to actually solve it out, plugging those values in, and we're going to find the square root of it to find the distance between these 2 points. In the end, we're going to round to the nearest tenth if necessary. So if we need to find the distance between 5, 3 and 1, negative 2, again, we just plug it all in. The distance equals our x2 minus our x1, and then squared, plus our y2 minus y1, and then squared. Now the question might come up, what if we switch these around? What if we went like this, called this 5, 3 over here? That's okay, you can mix and match if you want, but the first number, so this 1 and this negative 2, have to come from the same point. You can't do 1 minus 5 on this one, and then over here do 3 minus negative 2. Okay, then you've got everything kind of screwed up a little bit. You need to make sure that whatever one you start with over here is the one you start with over here. So 1 and negative 2 should come first, or 5 and 3 should come first. Okay, so in the end, after we got these all plugged in, we simplify it out. 1 minus 5 is negative 4. 2 minus 3 is going to become negative 5. Sorry, negative 2 minus 3 is going to be negative 5. Negative 4 squared, so negative 4 times negative 4 is 16. Negative 5 squared, negative 5 times negative 5 is 25. So we plug this in, or we'd add these up and get 16 plus 25 is 41. Type this into our calculator, get the square root of 41, which is going to be about 6.4. Now we wouldn't say it's exactly 6.4, we wouldn't say equals, we have to say it's approximately, so we use this squiggly equal sign. But in the end, this would be the distance between those. It's about 6.4 units away. Now, we can solve it all out this way and then plug it into the calculator at the end, or if you're very careful, you can start at this point, type that into your calculator, and figure it out all in one piece. And I'm going to show you how to do that here. So, our problem set was we need the square root of, in parentheses. Now, mine, I can see that there's an extra bar going over the top. Yours, you might not be able to. So put an extra set of parentheses just to be sure. Now, going back to the problem, it was 1 minus 5 squared. We're going to plug that in, 1 minus 5. Close my parentheses so I know it's this whole thing that's getting squared. That's being added to negative 2 minus 3. That whole thing squared. So negative 2 minus 3 is all being squared. And then all of this was still in the parentheses together, part of the square root. Now again, this calculator shows the bar coming over the top. Yours might not, so make sure you put this extra set of parentheses in the front and the back so that everything is happening together. Once you have it all typed in, you hit enter. Mine comes up and it kind of simplifies it. It lets me know it's the square root of 41. So then if I hit this up to D, it'll tell me. Yours will probably come out saying something like this. It is 6.4 with all these extra pieces at the end. So going back to our problem, we just type this in exactly, and we get that it's approximately 6.4. For this next problem, we're going to skip all this extra step and just type it into the calculator. So going from negative 3, negative 2 to 3, negative 7, this would be the distance formula. We just typed it all in. This 3 goes here, this negative 3 goes here, this negative 7 goes here, this negative 2 goes here. So we just moved everything into their positions. From here then, all we have to do is just type that exactly into the calculator. So square root of 3 minus negative 3 squared. So I'm going to start that off. Square root of, I'm going to start 2 parentheses, 3 minus negative 3 squared. And I'm going to add on another set of parentheses. Go back to the problem. Negative 7 minus negative 2 squared. Okay, so negative 7 minus negative 2, and that whole thing is squared. close my parentheses, so all of this is for sure underneath my square root. Hit enter. Again, this one will give it to me. It kind of simplifies it for me. I don't know if your calculator has that option on it. So yours probably came up as 7.81 with all this extra junk at the end. So we would simplify it or round it to 7.8. So all the work was done just by typing it into the calculator. So the distance is the square root of 61, which is approximately 7.8. And that's how you would find your distance using that distance formula. So again, find distance between the following points. Leave your answers in simplified radical form, no decimals. So in these ones, you can't use your calculator to figure out that end decimal point. You can use your calculator just on the inside part. So if it was our distance, we just plugged in all of these pieces, 4 and 5 at the front, 6 and -2 at the back. Okay, simplifying that down, 4 minus 6 is -2, 5 minus -2, so minus a negative is like adding, 5 plus 2 is 7. -2 squared is 4, -2 times -2 would be +4. 7 times 7, or 7 squared, is 49. Add those up, and you get 53. So on your calculator, you can do all of this stuff together and not have it underneath the square root, and it'll give you 53. So your answer, you'd say D is the square root of 53. Now, if we can simplify this, we should, but in this case, we cannot simplify the square root of 53. So we don't round it, we don't put any decimals, we just leave it as the square root of 53, because it says leave your answers in simplified radical form. For example 7, we do the same thing. We plug in all of our numbers, simplify it down. 6 minus -5 is 11. 4 minus -2 is -2. 11 squared becomes 21, or 121. -2 squared becomes +4. 121 plus 4 is 125, so we have the square root of 125. However, we can break this down. This is the square root of 25 times the square root of 5, because we can divide a 25 and a 5 out of that. Why did I pick 25? Well, because this is a square number. This is one that's on our list. So 1, 4, 9, 16, 25, 36, 49. This is a square number, so we know that this square root is actually 5. So in the end, we would say our answer for this in simplified radical form is 5 square roots of 5. Again, we don't type that into the calculator in the end. We don't reduce it in any way. We leave it as 5 square roots of 5. And I guess that'll be it for our lesson.